everyone enjoyed the pizza, and whoever stacked the pizza boxes up, thank you very much. So next up, we have Luke Oliff, who's going to be talking about building a BFF, which I believe is a backend-for-frontend or a best friend forever. We'll find out. If you can build a best friend forever in JavaScript, you probably can. This sounds like something I would do. Cool, so Luke works for Nexmo, so thank you very much. I know we have a little bit of a contingent of Nexmo people here today. Are you the only Nexmo person? Huh, just you two? Huh, I thought we were married. Cool, so thank you very much, Luke.
Hello. Thanks for that introduction. So, yeah, I'm going to be talking about building a There we go. Right. Screensaver. That's the problem. Building a BFF. So yeah, it's not. Besides being a joke about how I can't make any friends, yeah, this is a backend for front end. So we're going to be talking a little bit about that and a little bit how it fits into the microservices architecture and how it can just improve your general developer experience. So it's a little bit about me. Yeah, I'm a developer advocate for Nexmo. It's very enjoyable. Throughout the slides, you've got my Twitter and my GitHub usernames on there. So if you do have any questions about anything I mention, any corrections especially, then please feel free to reach out, and I'll always get involved. Okay, so backend for front end. It is sometimes commonly referred to as an API gateway. I found this out while writing about this, which is actually a term that AWS have made more popular recently. They have a product API gateway, and that does pretty much the same thing that you're going to see here. It will allow you to expose a small bit of functionality for a much larger service. So you can have a Lambda function, and you can expose it with an API URL. There are other services out there that will do this sort of thing as well. A backend for front end, it is one of these built specifically for a front end or a user experience. It allows you to separate the concerns and the functions of those user experiences. A good example of this might be call and message functionality. You may not want it in a web app, but you may want it in a mobile app. Yeah, you may want it in a mobile app, but you wouldn't want to expose that functionality through every API because it creates bloat where you may not want it. They themselves can integrate with multiple services as well, and they can interact directly with legacy code. This has featured specifically in my history as a developer, where we've been phasing out legacy code and we wanted to build an API, and we'll get onto some examples of this, but we basically built a thin API which could interact directly at the code level without having to build another API to integrate with it. So we could build our front ends in the way that we'd want to build our APIs on our microservice architecture in the future without blocking any of that. It allows you to phase out monoliths. So this is a design pattern that a lot of people, first of all, I should have asked, how many front-end developers do we have here? Hands up. Back-end? Data engineers? 1, 2. Yeah. Cool. So this may be quite familiar to everyone then, right? So it's a single application, something like a SaaS product, where you have a front-end web application. I say front-end as in where the client can log in and they can interact with your service, and a back-end where you can log in and you can manage them, and you can manage your users. You can delete them, block them, or even just generally manage them. Now this service, this pattern is actually a great pattern, but only if you have a very specific product to build, a very, should we say, a target, a goal in mind, and you're not looking at expanding too rapidly or too adventurously, shall we say. But then one day someone comes along and they say they want it on a mobile app, so you have to go and build an API into your into your architecture somehow, something I have been involved in, to allow mobile developers to interact. And then they want to upsell a load of products and services for other people, or they want to log more data out to third-party services, add a Google map, I don't know. But there would be tons of APIs to integrate with, and before you know it, you actually have a monolithic application that you didn't plan for. So this design pattern is prone to bloat, and it starts at the very beginning when you go, right, we're going to try and shoehorn this API into this larger application. So this is the better place to be in with the general purpose API. It could have been the first application, and then you've gone, we want to build a React app instead of like a static front-end application, and we want to do a mobile app. So rather than output our HTML, we're going to take it back to just outputting JSON payloads, and then trim down the monolithic application, make it more general purpose API. It does lots of things still. There is nothing wrong with that, but it allows you to separate those front-end applications. And then we get to our BFFs. So they are our friends, really. What they can do, and the most shocking thing can be just the sheer complexity that they can add. But what I'm going to get onto shortly is how thin that code can be to provide the additional functionality and the separation that it can give you, and how small it can then keep each of your services. That it will eliminate blockers where you're waiting for other people to develop code in the way you want it developed. You can build a small thin thing now, integrates into there in a way that you can get around blockers, and then build your front-end application. So I'm going to go and talk through building a very small BFF, and at the end, rather than do a live coding thing, because they terrify me, I'm going to do a live deployment, which is even more terrifying. A lot of people probably here will have seen this or something similar. Just going to initialize a small npm package, and I'm going to install Express. This is Express's hello world. So we're going to start from here, and it just outputs hello world as a HTML page. Make a small little change, and we have the world's smallest API. Next, I'm going to install using npx. I'm going to use npx to run create app React app. Create app. You don't need to. Yeah. Thanks, Orna. Create React app is what I ran. I have done this. It is working. So obviously didn't copy the right line. So yeah, ignore that bit. Create React app, and it's going to create a React app in the client directory of the package I've just created with our API. So we're going to have app.json, some package files, and then a client directory. In the 2 node module folders, and then we're going to then configure our newly created React application to proxy requests via Express, so that if Express does have any routes that match, then it will use those routes. Right. So one more quick change. We're going to basically tell Express not to run on the same port as React, because we want to run these two services next to each other. The whole idea of this is we're going to think of our front-end application or our user experience, and we're going to change it from being just this React app that integrates with an API, and we're going to think of that whole experience as two components, both a server and a front end, but not the server that you're used to dealing with. You're going to leave that where it is, and we're going to create a small server, and that's what this is doing here. So they need to run on different ports, but only for the development environment. So we're also allowing us to stick in an environment variable there. Need concurrently, because we're going to run them side by side in dev. So install save dev. And then we're going to write some scripts. So I'll run through these. So the first one is telling the express package.json file how to go into the client directory and start React. The second script, devs, that is just how we run the dev environment. Specifically a different line because, at least in how I would do this, I'd run like node daemon or something. So when I'm in the dev environment, I can make changes. I have to start and stop node all the time. Then just dev. So now I can npm run dev, and it's going to concurrently run both React and Express next to each other. React's going to nicely proxy request to Express for any API calls, and that's our dev environment. So we have a command in here for starting prod, and just a hint to what I'm going to be deploying to, the post build process. Right, so I said I'm not going to do live demos. I am tempted to, but I won't. So there are some screenshots here. npm run dev will now give me both my React application and my Express API response. Okay, so that's kind of straightforward. We've got concurrently basically starting two services for each other. At the moment, it's not doing anything other than that. So we're going to modify React. I'm not using hooks because I'm not cool. And I'm basically the thinnest of constructors here. Basically setting a default state of message is empty. Then component will mount, doing a fetch on /API. That gets proxied through to requests in our dev environment. The response is then set on the state. It's the data message. Then, if we have a message in state, then we're going to output, instead of learn React, we're going to output our message. All right? Next thing that happens is our output is then replacing the original text. So we can now change that output, refresh the page, and it's going to go back to the API, and all of a sudden we have like a data-driven front end. Now scale this up, and it can be, we use it all the time. It works really well. So this is the build and run. If you want to run this locally, this is how you would do it. So you can do npm install on your React environment, which you don't have to run every time, and then a build. So if you're running prod, you need to build your React environment. This is what we do in the production deploy. And then npm run prod, that just executes Express. So it doesn't work because we've forgotten some stuff. But the API endpoint does, and that's because we made the API endpoint, but we took away the root endpoint. So we need to add some roots back in there. So we're going to use Express to basically expose static content from the build directory. It's going to serve those files, and then we're going to do a catch-all to say anything else that doesn't get matched, we're going to then send to the index.html anyway. And then if you have React router, then it's going to do its routing then. So now the URL works. It's on a different port, because in this environment we have told it to run on 3001, and the API does still work. So what I'm left with is this deployable, and that button works, and I'll show you in a second, is a deployable like pair of components for both a front end and a back end. And in a perfect world, your Express application will be able to integrate with your original API or original legacy code or original monolith, and you start to move away from, very slowly, if you're wise, your monolith more towards like a microservices-based architecture. So I'm going to run it now. Any luck, it's going to work. Yeah, very. Need some like elevator music while Heroku does its thing. No one needs to see that.
Last time you saw me do this, my Heroku fell over horribly for the first time in my life. I might be an unlucky child.
So what it's doing here is it's running those the scripts that I've defined. So it's done the express, just it does a node install anyway, and then it's done just the node app.js. It's just running that express file. Then it does the post build where it's actually installing the React client and running React there. Running build on React there. You end up with a build directory, and then Express is then serving that static content. And for anyone who's interested, Steve's demo kind of runs on this architecture. At least I hope it still does. Your demo app, yeah. No, your demo app with the Backend-For-Frontend. Express serves view, right?
Yes, sorry, yes, it does.
Cool, right, deployed. It's working. And we have hello world. So our API is working. So there you have it. You have a backend and a front end. One serves the other. They're both built and deployed together, and you can think of them as a single user experience that's deployed as in one deployment. But is two concerns. It's still your logic separated from your display, and allows you to expose just the functionality you want just for that client, just for that user experience. And that's it.
Cool. Yeah, that was everything, right? Not just, yeah.